go. Here is the video I'm going to do for just pushes. I'm trying to think of what the actual name for it is, but pushes when you have to do, pushes. I'm gonna scribble all this out because I was just doing a little bit of practice, but I ended up scrapping that video because I thought I did something wrong, but then I realized I didn't, but then the video started to didn't make sense anymore. So say I'm actually pulling these problems out of chapter 4 of the pharmacology book. So if you want to try and follow along there, or if again this video doesn't make any sense, it shows you exactly how to do it there. But I'll make a video and walk you through it. So this formula is going to get you how to pull the correct amount of milliliters for however many mgs you want. So to start with that, the formula is going to be desired dose. So however many, if it's fentanyl, you want to give, or I should just say any drug. So say you want to give 50 milligrams of a drug, that's going to be a desired dose. So you plug that in there, but over it, you're going to take the dose on hand. And then that is going to be multiplied by volume, and it's going to equal your answer. Wow, my handwriting is terrible. But, so say the problem is going to be, you want to give Lasix. Lasix, the problem reads, administer Lasix 20 milligrams at an IV line. Lasix is supplied in a concentration of 40 milligrams per 5 milliliters. How many milliliters would you administer? So, your desired dose. So I'll give you everything. So 20 mgs is going to be what you want to give. That's your desired dose. Desired dose is what you want to give. And that's what you chart. The dose on hand is going to be, I don't like how this sets it up, but the dose on hand, what you have is 40 mgs. So DOH, dose on hand. But your volume is going to be times 5 milliliters. So by how you got the dose on hand and volume, dose on hand and volume are going to be kind of cousins, are going to stick together. The concentration you had was 40 mgs per 5 mils. So when you actually go to do this, all you're going to do is end up flipping that. Another way to look at it is, okay, what do I want to give? I want to give 20 mgs, and I have 40 mgs in 5 milliliters. How do I lose milligrams? By putting milligrams on the bottom in my next formula. Oh, that's a big no-no for Gary. But how do I want to get rid of milligrams? Again, 5 mils over 40 mgs. And what's that going to immediately do? Milligrams are completely gone from this conversation now. All I have to think about is, in my answer, is milliliters. So, here comes the math part of it, where you start simplifying things. How many do you do? 40 divided by 20. What is that going to get you? It is going to get you 2. Sorry, I had to think about that for a second. I don't know why. But 40 divided by 20 is 2. So 20 goes into 40 twice. How many times does 20 go into 20? 1 time. Now, what you're left with is 1 times 5. 5 milliliters over 2. So 5 milliliter. 5 over 2 milliliters. To make that just 1 straight up milliliter, or 1 straight up concentration or volume, so you actually know what you're going to give, you're going to divide 5 by 2, What is that going to get you? How many times is 2 going to 5? Well, 2 times 2.5 equals 5. So you're going to end up giving 2.5 milliliters. You found that. You found that by dividing 5 by 2. 5 divided by 2 is 2.5. Again, it's page 86 and 87 in chapter 4 of Jeffrey Guy Pharmacology. We'll do another question. This question reads, administer atropine and at 0.5 milligrams rapid IV push. The pre-filled syringe reads 1 milligram per 10 milliliters. How many milliliters should you administer? So my desired dose here is going to be 0.5. Let me draw a line here so we can take this problem out of consideration. So what I want to do is give 0.5 mgs. How am I going to get there? Well, my desired dose, my concentration on hint. I'm sorry about that. I completely am blanking on the name. But what I have here is 1 mg per 10 milliliters. But what I want to do is get rid of the mgs, because all I want to know is how many milliliters am I going to push here. Because I know I have to give 0.5 mgs. So how many mgs or how many milliliters do I have to push to get 0.5 mgs into George? And again, how do we cancel out? Things have to be on opposite sides. So 10 milliliters over 1 milligram. Cancel out milligrams. What am I left with? Just milliliters. There's nothing I can cancel out on math-wise, so I'm just going to have to straight up do the math. Multiplying 0.5 by anything is just dividing by 2. So 0.5 times 10 is basically dividing 10 by 2. You're going to get 5 milliliters. 5 milliliters is what you're going to push here to get your desired dose. And let's do one more. Again, try to do this problem on your own. Now that you know a little bit of the formula, try to do this problem on your own before I even start. So, administer. Let me cross this out. But here, you can just go to 87 in chapter 4 of Guy again. So we'll do question 4 here. So isotopin, 5 milligrams, slow IV push. So 5 milligrams is going to be your desired dose. The pre-filled syringe reads 5 milligrams per 2 milliliters. So what you can do here to make that one a little bit simpler is just immediately right off the bat figure out what the concentration is. So 5 mgs per 2 liters or milliliters. Just simplify that out a little bit. It's going to be 2.5 mgs per milliliter. So there you go with your concentration. So it's 2.5 milligrams for every milliliter there is. Now, the problem is calling for 5 milligrams. So 5 milligrams. Oh, Jesus Christ. That's not even in view at all. Well, basically just skip to this point, I guess, and hopefully that can kind of correlate. Sorry, I kind of screwed the pooch on that one. But what I have here is the 5 milligrams, and I have this solution or concentration. But what I can do here is how am I going to cancel this out? How am I going to get the milligrams gone So I'm just left with milliliters. Same thing again. Parentheses. 1 milliliter over 2.5 milligrams. Milligrams are gone. So now I'm left with 5 divided by 2.5. This is kind of a weird one. But how many times does 2.5 go into 5? 5 divided by 2.5. It's going to get you 2. You're going to end up pushing 2 mils. I guess another way you could kind of look at this, to be honest, is just leaving everything kind of in place, not actually doing the math here first, and just saying, all right, if I want to get 5 megs, and to cancel out that 5 megs, I'm just going to leave it, not even do the math here first. I'm just going to leave this here and switch it around. So 5 megs, 2 mils, and 5 megs again. What can I do here? Cancel. Well, first off, I'm going to cancel out the units. Milligrams are gone. And now I'm just left with 5 and 5. That can cancel out super simply. And what am I left with? Your answer's right there. Sometimes it's easier to simplify in the beginning. Sometimes you can just simplify like that. I found it easier just to simplify like that in that problem, but this chapter also has a lot of questions, and it was very instrumental for me trying to figure out the problems here. And I am a little bit confused sometimes on what is the concentration and what is the volume, I guess, the terminology, but that is the math. Don't quote me on whenever I say volume or concentration. I'm sorry about that, but actually in the next video, I'll try to look at that so I can clarify that a little bit better, but there's your math for non-weight based pushes.